Welcome back to our Scala to Spark class, and we will look at some statistical functions which are supplied by Spark engine, and also we'll start looking at grouping in using Spark syntax. So first start with some statistics. We looked at average, we looked at mean, and of course the next thing we can look at is variance and of course standard deviation. So let's go back to our book. Right, so again, if you have mean, right, so what's variance? Variance or standard deviation, they are measures how data is spread around the mean, right? So variance is, of course, formula is you have average of squares, right? And standard deviation is the square root of this variance, right? So again, you can use the functions. And another thing is that there are two different formulas, right? For those who have taken statistics, there's a sample standard deviation, also there's population standard deviation. So you might ask, what's the difference? Well, the difference is just one, division is by one digit, right? So if you go here, right, if you look at, in the Wikipedia is fine, right? You have a standard deviation, also sample, right? There's also sample. Right, this is standard deviation, and also there is also population standard deviation, right? And let's take a look at that one. What's the difference in formulas is that you have a where do we have it? It's basically it's a division of how many units you have. Again, it's number just one. It difference just one unit basically in division in the formula, right? So, but Spark supplies both. I mean, so both formulas for both types, right? So you usually have four different formulas we can apply. So let's take a look, right? Let's take a look at this, and maybe I will start with something very simple. We won't do with this. We'll do it with some more. Maybe slightly more simpler data sets first. Okay, so some number. Let's start day 28. All right, we close this. We have our project source, main, Scala, and day 28. New Scala class, object day 28. Statistics. Statistical fun, yeah, statistical fun, statistical fun, extends app, of course, right, add, extends app, and we'll do, let's see, so we'll do print line, chapter, we are still in chapter 7, statistics, functions, right? And we'll do Spark, of course, get Spark. Well, Spark, yeah. Right? Sparky. Okay. And we would like to get also a range. We have a range here, yeah, something like this. So range to df, right? We'll call it maybe something like this, right? We'll call some numbers, right? I'll do some numbers, right? Num_df. Maybe I guess I'll do this. Depends. Cancel. We don't need this, and of course I'll just do some simple numbers. Maybe can we do just this? Do we have a single number? I forget always. 10 is okay. Yeah, and we just do and, right? Df numbers. You know, nums. Right, something like this, right? Of course, this should show print line num_df show, right? Should be very easy, right? Let's run this, and again, this time I won't forget to run it from here, right? So we have simple numbers. So 0 to 9, right? I think there should be 0 to 9. Let's take a look. And Sparky should show 10 the nums column with these numbers, right? One partition. Again, startup is slow, so no matter if you have 500,000 data or you only have 10 units of data, right? 0 to 9. Okay, great. Okay, so let's get some stats, right? So let's get all the stats from the book, right? So we will show all the different stats here, except we will do it, right? So, right, variance standard deviation, right? And let's do this here. So I will not use quantity, I will use these simple nums, right? So quantity, of course, is control, I think H, right? No, how do you replace control shift R? Sorry about that. I think you can do control shift R. No, yeah, not in all, right? Sorry, not replace all, control, but control replace. No, I want to replace only in this file. Replace. Find usages, replace, right? Where is my copy and replace? I would like to do it all at once, but not only. I think Control F has worked also, right? Control F works, yeah. But oh, that's fine. But I want to replace it, not just say. Okay, Control H. No, that's not it. Control R. No. Oh yeah, here we go. Okay, quantity to nums, right? Replace all, and it's all nums. Okay, that's fine. But however, we need to, of course, and also nums df, right? Nums df, right? Was it num df? Yeah, num df is fine. And we need to have these variation population, import standard deviation, and import standard sample deviation. Okay, so let's take a look, right? So I will make it a little bit maybe slightly easier to see what's going on, right? And again, maybe I'll use here. Okay, right. So we have 4 values, and we should be able to see them. Okay, we don't need this anymore. How do you close it? Oh, here you go. Okay, so let's run it. And you'll see. So of course, mean. Maybe I should give a mean as well. You'll see the mean, right? And would be useful as well, right? We'll do that as well. So average is about 4.5, right? So you only see it here, right? Variance and square root, right? So the variance square root will be this, right? You can see that, right? Already covered this. Is, you know, square root of this is here, right? You agree, I hope, right? And so that's they're slightly different. The formula is basically if you have mean, let's do mean as well, right? Right, mean nums, I believe it works, right? And I need to import it. No, come on, pick up. No, it's not picking up, so I'll need to do it by hand. See, the popular words are not picked up automatically. Okay, so mean, right? And so let's take a look. All right, and if we do the maybe we could do the distance from the mean, right? So we could do this. How to do this calculation, right? If you do this here, right? So num df with column, right? Let's call it mean, right? We could do it basically. It should work actually. Let's see if this works, right? Mean nums, right? This is interesting, right? It's a single number, right? We just basically apply nums, right? And then we'll call name mean, right? Or right? And then I'll call it my mean. So n mean, right? Something like that, so there's no confusion, right? And then, of course, let's see if this works. I need dot. Sorry about this. Right? So here, right, and we'll do it here with column distance, right? We have the mean, so we have nums and mean, right? So with column distance, right? Distance, right, will be, of course. Let's see if we can do this expression, right? Will be nums minus n mean, right? Something like this, right? So you can see this exactly what's going on. I need to, of course, import this. Let's see how this works. Show, right? All right. Okay, let's see if this works. Maybe I made a mistake here somewhere, right? So of course this is the question, if this expression work, because I'm doing a mean as a single value. Maybe I had to do it separately. Right, let's see. No, it didn't work, unfortunately. It probably didn't work here, right? No, okay, yeah. So grouping expressions sequence is empty and nums is not an aggregate function. Okay, right. So nums, right, column, it didn't work here. Okay, average nums as and mean. Okay, average, right. I should probably do not like this, but I should do expression, right? Expression. Let's try this. Yeah. So this column expression. Average nums. Yeah, let's try that. Let's see if this works. Let's do one more try, right? See if this works. And mean, right? It should work. I basically want to show the average. I want to put a column of each average to show you distance. I'm not sure if this will work, because it's a single scalar value, of course, right? Will I be able to copy it? Maybe I need to wrap it again. No, I still need to wrap it. Okay, I still need to wrap it, unfortunately, right? Yeah. Okay. Yeah, okay, because this actually what we're doing is, of course, we're doing two things, kind of sort of apple and oranges, right? We basically want, it's in Windows function, we would need to get the value. Of course, I could just save it, right? I mean, that's possible. I mean, I'll just cheat for now, right? I'll do this basically, right? Of course, basically, with let's try this, right? So nums average, right, value average, right, equals what? And df, right, this column, right, I'm just doing it quickly on the not select expression, right, on average nums, right, on to int, I think, to string or to int. String to int. We can do to int, I think, or to double, right? To double. Let's see if this works. Again, we'll see if this works. Maybe I'm wrong, right? Print line average. Print line average. Let's take a look. So I'll do here basically call will be average, right? Right. Let's do that. Okay, average. And I guess I need to say column takes expression string. I guess I'll just leave it as string. Okay, let's see what happens now. I'm not sure if this will work. We need to cast actually to cast as. Okay, we'll see if this works. Okay, let's see. It might not. It might again. It might, maybe I'm trying. Like, basically, what's happening? Why the issue is because I'm trying to do row operations and also a single scalar operations, meaning you have single value. Yeah, still not working because we are right. Does not average. Average. Okay. Yes. Okay. Yes. Let's see. Column average numbers double does not exist. That's interesting. Where did I go? Nums is okay. Average number. This was what? It's a string. Right. But no, it's okay. It should be show or collect. Maybe I need to collect, and then I think I need to collect it, and then okay, that's a problem, right? Okay, so collect on first, right? Really? Is it really that silly? Right. I thought I could do it something simpler, right? This is getting too again. And get, of course, get 0, right? So this is again too much. Oh yeah. Get, and yeah, I need, of course, get. Well, I guess we'll get string, I guess, for now. Okay, 0. Now it works, but we'll see if this actually is correct. Kind of silly what I'm doing here, but again, this is, you can get around quickly. Again, still not working today, so something not work, right? Double cannot be cast to. What's interesting? That's very interesting. So get double, okay, that's fine. However, this is now you have to go back and forth. So this obviously is not. This is so very wrong way. So this is to do. Fix me. Find an easier way to assign average to all columns, all rows, all average to all columns, right? Basically, we're trying to get average assigned to all of the values. Well, again, slight little detour on. There should be an easier way, right? Again, it'll be very. Okay, still not working. What's going on today? So this today is not really. 4.5. Okay, that's very good. On the right, can we just basically say this? Can we just apply a line? Would that work? Could that work with column? Right. So 4.5 does not exist. Do you mean, okay, so exception was this, right? Column 4.5 did not work, but we want to assign a value. Literal, right? Literal. Lit average. Okay, yeah, sorry about that. Yeah, we need to import that. So yes, good. Okay, now kind of silly, right? So we assign average to all of the. So with two-way. Again, this is a long way around. I think you can do all of this combined here. There should be a way of doing it, right? Maybe I know it. You probably do this literal to this expression. That's probably what you want to do. So because all of this, right, you can put it here, but there should be another way of doing it, right? Because this is double. Now the math should work, right? Yes, okay, and of course, since okay, so statistically this shows, right, this is now correct. The problem, of course, is that this is distance squared, right? Distance squared, right? So, and then, right? So, Control D, right? D squared, dist square, right? Will be, of course, distance times distance, right? Right, let's do it one more time, right? And then we'll be able to see where these numbers come from, right? So something very simple. Yeah, okay. So now we have these one numbers. So again, so now you see why in statistics they use square distance. Why? Because you don't. So now you have these values basically as a so to say. How should I say? You know, negatives and positives, right? Now you have all these and positives. So now the variance will be. Let's see if this is correct. How do we get this number, right? So get these two numbers. Let's take a look. Let's save this, right? Val full distance, this df, right? I'll call it something like this, right? And now, right? show, right? Now, of course, I will do the. Let's do it. See if we can do the variance or own variance, and let's see if I remember my math correctly, right? So we'll do it in the. We have these numbers. So we want well this df. We select basically select expression, right? We'll do that. We'll do or select basically. Yeah, let's select expression, right? We'll do sum count. Basically, sum this squared, right? Divided by count this squared, right? That should work. If I'm not correct, if I hopefully am correct, right? And show. Let's see if this works. All right, let's see if this works, and that should give you variance. Should be as variance. So that should be the formula. So in a roundabout way, this should be the variance. I hope I'm spelling it correctly. Yeah, 8.25 exactly. You see? So that's how we arrived at variance, right? So by the same as variance, and then also this will be or sample variance will be, if I remember my math correctly, will be sample variance will be -1. Again, if I remember my statistics correctly, so this will be sample variance. And again, sample variance is yeah, variance. Where is it? Our population. Okay, okay, right. So this is yeah, sample and sample variance. Right? Regular variance, regular variance. And so basically use again, it's a, if you read your textbooks, look up in statistics textbooks for explanation. Again, it's used for some different things basically, but again, of course, they both describe how data is distributed, right? So okay, let's do this. I hope I did correct. Oh, yes, I didn't do it. Sorry. There will be an error. Yeah, I see there's parentheses missing. Okay. Yep, there will be a red. Come on. No, it was not red. Oh, yeah, actually, no. I guess not. Oh, no, everything's correct. Oh, yeah, everything's fine. Okay, so you can see exactly how my own formulas came up with the same thing the SQL did as well, right? So now you can see what happens. Of course, also I can do with column again, standard deviation, of course, and then expression. How was it? Square root? I forget now. SQL power, I think, right? Right, power or square. I think it was square root, right? Square root. I think there was a built-in. Yes, square root. Okay, that it works here. Okay, so we can do that. Okay, so as you can imagine, this will be. Again, I want to be very thorough in this because this is important. Variance, right? And of course, this will be one more. Oh, there's dot. There's dot, right? And we can show it. Right? Right. Okay. So we have derived our own the standard deviation and standard sample standard deviation sample and of course this one here, right? Commands Control Z. Yep, okay. And now this should complete our stats overview. Okay, so yes, it should be exactly the same. In fact, that's exactly what it is. You see, right? It matches my formula. Is actually same as what's supplied by the SQL. Okay, let's continue then. Okay, so here we spend maybe a little bit too much time on this, but let's go on to other stats, right? So we can see that our stats are same, and so we can see my formula matches. And let's go more. Yep. So these are measurements again. So skewness and kurtosis, right? These are right. You can look up again. You will have to look up your definition if you're interested in statistics. They measure how asymmetric the values are around your mean, your average, right? Again, maybe I'll give you a little link to kurtosis to this, right? All right. Oh, not here. Sorry. Kurtosis, right? How it's there's also a formula. I don't have time to do it again, so it's standard deviation, right? There's a formula, right? It is what kind of skewness, right? It's a way of describing how data is centered, right? How it's skewed around the mean, basically, right? Right? Negative skew, positive skew, right? Again, right? So mean and median, right? It's not directly right. But right, you can find so positive skew, median mean mode, right? Symmetrical distribution, right? And negative skew. You have the tail. What very tail is, right? Long tail is to the right, long tail to the left, right? Again, right. And then again, I won't go into all this discussion. That's you can look up this data in yourself when you have time, right? But again, they show also kurtosis as well. So basically we'll use it, right? And we will see how well there's big number, small number, right? Basically I will use this, right? And SQL as well does it, right? Yeah, df select, right? Of course numdf, right? Right, and I need skewness and kurtosis. And of course nums, right? And now of course if I did this with if I did it, I have to make also create a or temporary view. Where's my Spark utilities, right? No, my Spark utilities. Yeah. All right. Now where is my? Do we have all the data? Okay, we'll do it from here, right? This def, right? We'll do it here. Distance, no, actually just regular numbers, right? Just regular numbers is fine. Yeah, actually we can use this one here. Okay, I'll use this one here. Right, this def, and we'll call df table basically. Right, so you can see this. Of course, you can do this also from SQL, of course, right? It should be same thing, right? So Spark, SQL, right? Right, triple quotes, and we can do it also with SQL, right? Just like this here, right? And of course, I need to have this nums, right? Nums and nums, right? It will be interesting, of course. In this case, there's no skew, right? There's no skew because, well, it should be right centered, right? Basically, if you think about the middle, right? It should be. We'll see how this how it's shown, right? Strip margin, and we'll show it. Right. Okay. So for now, these are all single column aggregations, right? Yeah, it worked fine. So of course skewness, right? That makes sense, right? So 0, right? So skewness should be skewness should be 0 because, well, the data is perfectly centered around mean, right? And kurtosis, again, there's a formula for kurtosis. Let's take a look. Kurtosis, again also similar, but it's not as, the formula is something like this. So E, this is force in a moment, standard deviation, right, which we already have. Some things we know, some of things, these are again not as easy to calculate, right? So, right, and it used to be settled, right? So right, so people actually even used to talk about what exactly, how to interpret exactly this, right? So, but again, it's talking about how data is distributed. So skewness is probably more logical to see. Okay, let's move on. Again, statistics, and lastly but not least is we have a covariance and correlation. So what are we talking about here? Well, correlation is basically how are these two columns, how are they related? So let me show you what I'm talking about. Correlation, right? In those who have not seen, it's like some picture, like this picture here, right? Okay. Oh, nice big picture, right? So if you have a blob of nothing, random data, meaning x and y, two columns of data, right? These are basically, there's no correlation whatsoever, right? If you have a positive correlation of 1, means perfect correlation. That means there's a linear, so correlation is a linear relationship. It shows if there is a linear relationship between two pieces of data, right? So you have negative, perfect negative correlation. Again, one value is increasing, one value is decreasing. And notice also how the slope, right? It's still 1, right? This is all 1, right? Still, and then it's negative 1. So slight slope up is still 1, right? Correlation wise. However, notice the minus. What's the problem with correlation is that sometimes the data is not linear. There's no linear correlation, right? There's some other there's also some pattern in data, but it's not linear. So it's not going to be your one catch-all solution, but it's a good way to see if there's any linear correlation between two pieces of data. So okay, I guess I'll need to show this, right? Right here. So right on the right. So right, and again, they both covariance again also have this sample, this off by 1 question. So now I need, of course, df, right? I'll need to use df because I don't have the data. What is the quantity, right? Invoice, yeah, okay. So I'll load something. So I'll load maybe df. That's interesting if I'm going to rename this. So val df is equals load, what do we call it? We call it read data with you, right? Yep, that's the one I want. And I want I'll just load some basic. I won't load. I don't need everything. I'll just load single day, basically. Let me see. Resources, CSV. No, retail data by day. I'll just load 1 day, right? Copy. Let's get a path. Fine. Where's my copy path reference from root, right? Right, okay. And is there any problem? No, there shouldn't be any problem. What do I need? Ah, yeah, I need a Spark, right? I need Spark, right? Yeah, okay. Okay, now we're good, right? And let's see if this works now. Example should work, right? So there's 3, right? df I have. So what's the problem? This should be a data frame. What's happening here? Sorry, I didn't close it. Yeah, it's fine. Need to, of course, import core, import covariance sample, import covariance population. Okay, let's take a look at this, right? Okay, let's see what they come up with. Because my other numbers I didn't have a correlation, right? It's unlikely invoice number and quantity are unlikely to have a covariance, right? Because I'm sorry about this, but yeah. So of course, so there's no correlation, right? It's almost slight negative correlation. Of course, it'd be it would be strange indeed if invoice number had some noticeable correlation to quantity of items ordered. I mean, there might be. I mean, it could be maybe. I mean, it could be if that later customers, buy bigger batches. Maybe different promotion or something, right? Or different sales team, right? It is possible. I mean, it is not. I mean, it is not completely out of question, right? But still it would not be. It's still correlation does not imply causality, right? That's. I think that is a saying, right? Famous saying, right? That is, yeah, causation, right? Causation, right? Yeah, right. So it's not again. So that is again. I'm going with Wikipedia, of course, because but you can explore right this causation, right? Causality again, but. As the joke goes, maybe it winks at you and says, okay, maybe there's some, but it winks and says, look here, something is interesting. I mean, again, beware of wet streets cause rain fallacies, right? So beware of these wet streets cause rain fallacies, of course, right? But you can find correlations in everything. There's also, of course, again, funny correlations, again, funny correlations, right? You can find them with anything. Spurious correlation, yeah, that's the one, yeah. This is pretty much faint, right? So pretty dark, right? You just do a refresh, right? Maybe find something interesting, right? Again, something else, maybe. I want something else. Right. Films who drowned by falling into the pool. Films Nicolas Cage appeared in, right? And so on, right? Again, so divorce rate in Maine, per capita consumption of margarine, right? Pretty nice correlation, right? So surprisingly, correlate age of Miss America, right? And so on. Right, this might be a question, right? Arcades and doctorants in computer science, there's a huge correlation there, right? And so on. Again, so this is a very, very interesting study. Okay, so that is basically all I want to talk about statistics in this regard, right? And what else does books talk about? The book mentions that you can also, right, you can do aggregate to collect. You can collect into lists, right? So not just formulas, you can also collect a list of values, right? And basically you will collect everything into a single big list, basically. Maybe you need this. So why would you want this, right? Collect set or collect list, right? Why? So what's the difference? Set would be unique, the list would be everything, right? So this is something for maybe you need to collect the different types, right, for later access, right? Right, so that is something we might want to see. Alright, and this will be pretty big, right? Sorry. So aggregate already, right? So on without groups, this is we do aggregation on everything, and we basically collect country on two list set, unique values on just everything, right? Let's take a look. I'll do truncate false. So of course we'll see everything in a big of false, right? In a big. I think we are almost done. I think we will get to grouping next, right? Okay, as you can see, set is 1, 2, 3, 4, 5, 6, 7 countries, right? It's unique, right? However, this part here, oh my god, look at this, right? Huge list, right? You can see exactly the difference between these two. So set will be uniques, right? On country on the list will be everything from some row, right? Again, of course, how would you get out? Collect, right? We could always, of course, collect into rows, right? We could do other things, but this might be useful if you are passing it along, right? Collect set, for example, right? So again, we can always use Spark SQL. Same results, should be same results exactly, right? And this should work. Right, false. Right. And notice here, right? Notice by using that function, we redefined df table, which is the default for the above function, right? So we have we redefined virtual or view called, right? That's just something to notice. Okay, so this should be also something we can use. Okay, as you can see, collect set, correct list. How did I do this? That's not my part. Yeah, it's that's their problem. They did it wrong, right? Set list, again, a lot of editing is wrong, so they did a bad job of editing. Well, we are almost running out of time. We'll do an exercise next. As you can imagine, again, most of these things are already done by the scribe. Yeah, so it's exactly the same thing, same result, right? Big list, right? So complex types, right? We can get aggregations into sets and lists, right? And then, of course, we can extract this outside and get an array and basically have a list of countries, right? So okay, so let's see to do again, load March 8, right? Is there March 8 of 11, right? Yes, there is March 8, and let's do of 201, right? Let's see, let's see average, standard deviation, variance, standard deviation, regular ones, the regular ones, and then correlation, skew and skew kurtosis, and correlation, and standard covariance, right? And standard right, on population covariance, right? Okay. So let's show. So it should be pretty easy, right? On CSV. And let's see what else can we do. Right. And now let's see if you can collect unique countries out of a set. So transform unique countries for that day into a regular, Scala array of strings, right? So see how that works. That might be something, an extra challenge, right? Something a little bit more, right? See if you can do that. So you basically want to transform this into a regular array. So you could see probably you can use get, right? You can have what we did here, right? You can probably use something similar what we did here, right? When I was fighting with the average, right? Something like this: collect head, get double, maybe get array, right? Because I think you have a I won't break it, but get. No, you don't have array. Get. You don't have it actually here, but I think you get string maybe, and then you can split it. I think there should be some way, right? Control C, how it works, right? There might be other ways of doing it, right? You can do set, right? I would like to see the unique countries. Okay, see how you do it. You can use distinct. You can, of course, you could use SQL distinct, right? Of course, right? That's also would work, right? Do not have to use collect set, but you can, right? Okay. Let's see. Well, that will be it for today. Thank you, and we'll meet at 9.